Hey everybody, this is Mr. B here. I'm going to show you guys how to go through lesson 301, cubic functions. Now the first thing we're looking at is a warm-up, and we want to evaluate for the following inputs. You will notice that we have two different functions, f of x and g of x. So at this time, go ahead and pause the video and solve f of 4 and g of 4. All right. Let's go ahead and see what the result is for f of 4. Now, because 4 is an input, that means you're replacing all the x's in the original function with a 4. We're going to go ahead and follow order of operations, which is PEMDAS. So we begin by solving the inside of the parentheses. 4 minus 2 is 2. And as we go through order operations, we can cross out the steps that we've already done. 2 squared is 4. 3 times 4 is 12. And finally, 12 plus 4 is 16. So we find that f of 4 is 16. Let's try g of x now. So we have g of 4 equals 4 minus 2 to the third power now, plus 4. Great, 4 minus 2 is, once again, equal to 2. In this case, however, we have 2 to the third power. Now, remember, 2 to the third power does not mean 2 times 3. An exponent is telling you that you're going to multiply your base by itself that number of times. So if we have 2 to the third power, that means we have 2 times 2 times 2, which in this case is 8. 3 times 8 is 24. 24 plus 4 is 28. Okay. So even though the functions look very similar, in fact, they have the same numbers, one of the big differences is the exponent. We do not have the same exponent for these two functions. So as you can see, something small, like having an exponent of a 3 instead of a 2, can change your answer pretty dramatically. Now, let's go ahead and take a look at some guided notes and see what the cubic parent function looks like. Now, what you're going to do here is you're going to take every input, inputs being the left side, which I'm highlighting, you're going to plug them into this function here in blue. Now, let's go ahead and do the following. Negative 3 to the third power is negative 3 times negative 3 times negative 3. Which in this case is negative 27. You kind of get the idea. Negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 times 0 times 0 is 0. 1, 1, 1 is 1. 2, 2, 2 is 8. 3, 3, and 3 makes 27. So these numbers, although they are the same magnitude, do not have the same sign. So we're going to see how that affects our graph. All right. We have our first point at negative 3 and negative 27, which is down here. Our next point is at negative 2, negative 8, which is right here. Then we have negative 1 and negative 1, 0, 0, 1 and 1, 2 and 8, and finally 3 and 27. Now, unlike a parabola, we do not have a symmetrical looking shape. Ooh, this is not really going through the points, but it's really difficult on my end. As you're doing this, ideally, you are going to the points, okay? So anyway, like I was saying, this is not a symmetrical shape, so the left curve does not match the right curve. This is no longer a parabola. This is a squiggly. Now, the locator point is very simple to determine because you're looking at the flattest point on the graph, which in this case is 0, 0. Okay, now let's discuss domain and range. First off, let's identify what domain means. Domain are all of your possible x values. What are your possible inputs? Now you'll notice that I'm highlighting the entire graph. There's a reason for that. As we go to the left, we are going forever to the left. There is no limit as to how far left I can go. So if we have no limit, we can go ahead and say that we're going towards negative infinity. As we go to the right, our arrows tell us the same thing. We're going forever to positive infinity. So our domain looks like this, negative to positive infinity. The range is the same. Instead of going left and right, now we're looking at up and down. We're going down forever towards negative infinity and up towards positive infinity, which gives us the following range. Okay, great. I'm going to leave this section to you. What you're going to do is you're going to type in this code into student.desmos.com, and you're going to go ahead and play with the sliders. You should pause the video here to do that. And I'm going to show you what you were supposed to come up with ideally. Now, first off, let's identify the following things. We want to circle the input. We know x's represent inputs. Now, f of x is an output, which means that the entire function itself is an output. And we're going to introduce you guys the idea of parameters. Now, parameters are these letters here that affect the way that our graph looks. A is a parameter that affects your width, and it can also cause your graph to reflect or flip. H is responsible for moving your graph left and right, while K is responsible for moving your graph up and down. Great. With that in mind, we can move on to the next section. How do we write an equation when given a graph? Well, it's real simple. Step 1, you want to identify the locator point. Now, we've already established that the locator point is the flattest point on your graph, which in this case, it would be the point that I highlighted in blue. The locator point is your H and K. You want to pick a second point to serve as your X and Y. I'm picking the point 0, 3, which happens to be my Y-intercept. This is highlighted in yellow. Now, what you want to do is you want to rewrite this function here. Y equals a, x minus h to the third, plus k. So we're going to go ahead and begin with that. Y equals a, x minus h to the third, plus k. Great. We're going to replace x, y, h, and k. That's the second, that's the second step. So we know, I'm going to go ahead and label this just so that you guys know what points I'm referring to. We have the point -2 and 1, which is my h and k. And we have the point 0, 3, which happens to be my x and y. So I'm going to replace y with a 3. A, we don't know the value of. X is 0. We have a negative, which is part of the equation. H happens to be -2. All of this is being raised to the third power. And k is +1. Great. Now let's go ahead and solve. As we're solving, we want to do PEMDAS, at least to clean things up. So we're going to begin by evaluating the inside of the parentheses. 0 minus -2. We have a case of a double negative. That becomes 0 plus 2. So 0 plus 2 is 2. 3 equals a, 2 cubed plus 1. 2 cubed is 2 times 2 times 2, which is 8. 3 equals 8a plus 1. Great. At this point, we are no longer using PEMDAS. Now we're using SADMAP. The reason for that is because we're working backwards to solve for the value of a. That's going to require me to subtract 1 from both sides. Oops, not -2. Should be +2. 8a equals 2. Let's finish off by dividing both sides by 8. You always want to divide the coefficient. Coefficient means the number in front of the variable, which in this case is 8. So 2 over 8, unfortunately, is not simplified. We would need to simplify that. Both of these numbers are even, so we can divide top and bottom by 2 to give us a final answer of 1/4. Now, this is part of your final answer, but it is not the entire final answer. Your goal is to write an equation. So you're going to rewrite the original equation that you started with, which I'm now highlighting in yellow. But we're going to replace hk and also your newly found value of a. So we'll begin by writing y equals 1/4 x. Now we have x minus -2. Since we have a double negative, we're going to go ahead and need to replace that with a plus sign. So x plus 2 to the third power plus 1. So here in orange, underneath the graph, we can see this would be the final equation. Once again, if you guys have any questions, please comment them down below. I'll try to answer them once we are in class. Or I can make an extra video on answering, all the questions you guys may have. Okay. This is an example for you. So you can go ahead and take this time to do it on your own. Just for reference, if you are done, you can confirm your answer. This is what your answer should be. Y equals -3/2. X minus 4 to the third power minus 2. Great. If you have the Desmos code open, then you're working on completing screens 6 and 7. Okay. This next portion is going to require us to use a calculator of sorts because it is a lot of steps, but let's go ahead and dive into it. So now we're working backwards as opposed to the last problem where we were writing an equation. Now we have the equation, we want to graph it. So what should we do? Well, one of the first things you need to do is to identify the locator point. Now we know what the graphing form of a cubic function looks like. Y equals a, x minus h to the third power plus k. So I can easily tell that my h value is -5 and the value of k will be -4. The values of h and k will always need to go in the middle of your table. So I have -5 and -4. Now I need a sequence of numbers. So I will write the numbers that come before -5 and the numbers that come after -5. And these are my inputs. I need to find all 4 of these inputs. Okay? Great. So we need to start by finding f of -7, which means we're going to plug in -7 into the function h of x. Oh, excuse me. That should be h of x, not f of x. H of -7 is -2, -7 plus 5 to the third power minus 4. Using PEMDAS, you're going to solve forwards. -2, -2 to the third power minus 4. -2 times -8 plus minus 4. 16 minus 4 is equal to 12. So your output for -7 is 12. You can go ahead and pause the video here to solve the rest of these. Okay, so by now you should have solved all of these. I'll give you guys the chance to check your work. These are the outputs that you should have gotten. So for an input of -6, your output should be -2. For an input of -4, your output should be -6. And finally, for an input of -3, your output should be -20. Now, the goal is to graph this, so let's go ahead and begin. -7 and +12 would be a point right over here. Then we have a point -6 and -2. -5 and -4. -4, -6. Finally, -3 and -20. All right, I'm going to try real hard here to go through the points. There we go. So we get a squiggly. Great. This is what your solution should look like. Perfect. You're going to try the next one. Pause the video at this time to try this problem on your own. Okay. Let's move on. How do we solve cubic equations? It's real simple. You just need to plug them in. Let's find f of 4. F of 4 is the following function, x squared. So f of 4 is 4 squared. Well, that's really easy. 4 squared is 16. Okay, let's do the next one. What is f of negative 4? Well, f of negative 4 is negative 4 squared, which is also 16. Excellent. Now let's look at outputs. What if instead we're given the output? Well, now you need to set your function equal to the output. X squared equals 25. Okay, to solve for x, we would need to square root both sides. X equals plus or minus 5. All right, what if the output is now negative 25? That shouldn't change things, should it? Let's take a look. X squared equals negative 25. Now, I just did this problem, so I know I should take the square root of both sides. But no matter what number I try, I can't find a number that when I square it, I get a negative solution. Now think about this. Positive 5 and positive 5 make positive 25. Negative 5 and negative 5 also make positive 25. So this is actually not possible. It is not possible to get a negative output or find a negative input that gives you a negative output with a quadratic function. Or, in this case, we're solving for the square root. Now let's see how that differs with cube roots, or cubics in this case. I want to find g of 8. So g of 8 means take the third root of 8. Now, this might be new to you, but the cube root is the opposite of a cubic. So I'm now looking for a number times itself 3 times, that gives me 8. Well, I know that number is 2. So my solution is 2. All right. Same problem, different input. G of negative 8. It's the cube root of negative 8. So same thing. Some number times some number times some number. Well, ideally the same number, of course. Gives you negative 8. Well, that number is negative 2. And that's your solution. Okay, so what's the deal here? Why did we just go through this? Well, the reason why we did this, you guys, is to show you that it is possible to have a negative input and a negative output when you have cubic functions. Okay? All right, so let's go ahead and do some more challenging functions with some transformations, starting with h of negative 1. H of negative 1 is 2, negative 1 minus 1 to the third power minus 2. This is the following. 2 times negative 8 minus 2 is negative 16 minus 2, which is negative 18. I went through that kind of fast. Please pause the video if you need more time to do it. But we get the solution. Now, you want to try the next one on your own. So you may pause the video here. And hopefully you are done solving that problem now. So let me give you the solution to check your work. H of 5 is equal to 126. Great. So with an input, like the name suggests, you're just plugging it in. It's an input. Plug it in. Okay. For what values of x, or for what value / values, because there may be more than one, do we have an output of 14? Okay, so this is going to require you to set your function h of x equal to 14. 2x minus 1 to the third minus 2 equal to 14. To solve a problem like this, you need to follow the following steps: backward, PEMDAS, or StatMap. Great, so I'm going to start by subtracting. In this case, I can't. I'm already subtracting a 2. So I'm going to do the opposite. I'm going to add a 2, plus 2, plus 2. Okay, 2x minus 1 to the third power equals 16. Let's move on. We divide both sides by 2 now. X minus 1 to the third power equals 8. Okay, at this point, we need to cancel out this exponent. Oops, excuse me. The only way we can cancel this exponent out is by taking the third root. So you draw a square root symbol and you put a 3 in the front. This symbolizes a cube root. So we get x minus 1, whoops, equal to the cube root of 8, which is 2. We finish by adding 1 to both sides, and we get a solution of x equals 3. You will notice that we only get one solution. When you are dealing with cubic functions, you will only get one solution. Pause the video to try the next one on your own. Okay, by now you should be finished. H of x equals negative 130. The only value of x that makes this a true statement is when x equals negative 3. Okay. The rest of this lesson is for you to solve. Thank you for watching. If you guys have any questions, please leave a comment down below. All right. See you guys in class.